Today we're going to tackle a independent samples t-test. I'm using some real data that I and some students collected a few years ago, and this was something of a replication report. We wanted to make sure that the original Benjamin and Oelke findings were replicable. In other words, that once we ran the initial analysis, the initial experiment, that if we ran a second experiment using the same methods, that we would manage to get a essentially the same results, hopefully. So what you can see here are a number of things. There's really just a ton of variables just to be aware of. So, for example, we have the treatment condition, which is the effectiveness frame. Torture was framed either as effective or ineffective. Otherwise, it was just a matter of emphasizing how much of an impact torture made on getting some individuals to confess. And then we have several questions that make up the attitudes towards torture scale. Those get averaged into an overall attitude towards torture score. You can also see some other demographic variables. Okay, so when you look at the data, this is what you're seeing, but this is how a data entry template would actually appear. Now, you'll notice that I have a lot of non-numeric values for some of these variables, and that's because when I was in SPSS, I was giving the values such as condition, for example, value labels to indicate whether the person had been randomly assigned to the effective or ineffective condition. And then you can see towards the end the attitudes towards torture scale scores. I used an average just because it would be a little bit more intuitive for people to get at. You'd get the same essential findings either way in terms of a t-test. So I'm not too terribly worried about that. But that is kind of how I tended to work things. Now let's get to analyses. We're going to do a t-test here. We're going to select independent samples t-test. And when we do that, of course, we're going to start to see some items appear that we're going to want to populate. And so one thing I'm going to want to do is I'm going to want to go ahead and get my effect size. I want to go ahead and get descriptives because I always do that. And you can see that it's already getting that table set up for me. I want to check for homogeneity of variance to make sure that the variance in the treatment and control groups are equivalent. I also want to go ahead and do a normality test just to make sure that assumption wasn't violated. Okay, for grouping variable, I'm going to include CO and D for condition. For the dependent variables, I'm just going to include one, which is this one called TORAD, which is attitudes towards torture. And so once I do that, you'll notice that my screen will become populated here with some statistics. For example, you can see that the t-test is 2.46. There's 98 degrees of freedom, which makes sense because there were 100 participants in the total sample, 50 in the treatment condition, 50 in the control condition. P-value is at 0.016, so still statistically significant, which is good. Cohen's D was at 0.49, which oddly enough turned out to be roughly half what we obtained when Oelke and I did our work together, which actually falls in line pretty well with what we know from the open science collaboration paper from 2015, which is something I will introduce you to a little later in the semester. In terms of assumptions, we don't have to worry about normality. Normality was not violated. Homogeneity of variances. Um, I can see again that the p-value is non-significant there, so the variances are equivalent in each condition. And that seems to, if you were just simply eyeballing the descriptive statistics, it would be pretty obvious right here that the variability is very, very similar across the two different conditions. You'll notice the means. People tended to be kind of right in that middle ground as far as their torture attitudes went and the ineffective frame condition and the effectiveness frame condition. The mean was, you know, a bit noticeably higher and obviously statistically significantly so. And folks tended to be a bit more favorable in their attitudes towards aggression or torture. Okay, and you can see the standard error terms that would be used to eventually create the pooled standard error that we would end up using as the denominator for the t-test. Okay. Again, just in case you're curious what the R code would look like, I'm going to go ahead and put this in syntax mode for just a second, and you can see what the R code would look like. You can see that we define what the formula is, our data, where they're going to come from, since it literally comes, we already have the data preloaded. We're in pretty good shape. We have our variables. We can see the normality and homogeneity of variances tests defined, the effect size test defined, descriptives defined, and so on. So all the coding has been done for you, but if you were to code yourself, this is how you would code it. Okay, so I'm going to go ahead and get out of syntax mode here. Again, don't forget to save your file and be prepared to upload it to assignment 3. Okay, so that is where we will end. That is for those of you who are not able to make it to class. Hopefully this video helps. Thank you, and stay safe out there.